Okay, so let's see how we implement the binary search tree library. So the first thing, let's focus on this for getter function and the setter function. So we start from the getter function. We have the square bracket getter function and the containsKey getter function. So let's go back to see how should we search. So just like earlier we say, right? So if you have the key is Mary, so the first thing we will start from the root node. So then we will see the root node P key if greater than our target searching for key. If this one is greater, so I go to the left. Otherwise, I go to the right. So once we go to the left and right, so then when we finish, we go to the end of the tree. So then actually we just finish. So that's why here you will see when you need to traverse around, you just need to start to point to create a node is P. So this pointer equal to the root node pointer. So then you're using this one to access the key to compare our target key. So if the target key is greater, so then I will assign the P equal to the original P right. So then we just compare again. So as long as P not equal to 0, you see, because if you see if the Lucy is try to assign the left, but you don't have the left, then that means you are end of the tree. So that's how we will have the for loop. So let's see how we implement our getter. The first thing is containsKey because they are all very similar. So that's why we will do the same thing here. So the first thing I need to have a node P. So this P I need to assign the root node. So then after the root node, right? So actually what we need to do is while the P not equal to 0. That means so P not equal to 0, we continue. If P equal to 0, we finish. So then in this while loop, right? So we just need to do what? We just need to check. Okay, so if the first thing P refer to the key equal to the key we passing. So then what should I do? Right, so I find that, right? So when I find that, because that the containsKey, so we just return true. Okay, otherwise, right? Otherwise we continue. Else if. So else if the P not equal P the key not equal to our key. So how about greater? So if the P refer to that key is greater than the key we're looking for, so should I go left or right? So right, this one is smaller, right? So that's why we go to the left. So P equal to the P left. Okay, so otherwise, so then again else, our P will go to the right. So now if you finish the while loop, then you had not returned anything, right? So that's why I mean we didn't find that, so we return false. Okay, so that's the containsKey getter function. So that's containsKey getter function, right? So how about the containsKey getter function, right? So don't forget we have the COMSC keyword. Okay, so that's containsKey getter function. So then we have the next getter function, right? So that's we have the operator square bracket getter function. So again, we pass in the key. But here, if that's the getter function, right? So we return the copy. So will be different. Yeah, they are the same, right? So the same thing, your P start from the root P. If P not equal to 0, so then we continue. So if the P key equal to, refer to the key equal to the key we're looking for. So now this one, we don't return true, right? Okay, so right, so we return the value, right? So P value, so that's our return. So if you find a match, you return the P value you point to. Otherwise, we continue to do the searching. So else if your P is the key is less than the key we refer to. So then we go to the left-hand side. Otherwise, we go to the right-hand side. But if we finish everything, so then they didn't find that. So that's why when we got this point, that means we didn't find the match key. We finished the loop. So that's why for the not find that, we return the default copy. So that's the square bracket getter function, right? So how about setter function? So that's why when we have the setter function, right, we will return a V reference. But one thing is, do we still have this? Actually, we kind of have that too, right? But just the only thing is, right, so if we find that the match key, so then we will return the p-value. But if we don't find that, okay, what should we do if we didn't find that? Right, so for the setter function, square bracket setter, if you didn't find that, we need to add the new node. The problem is, how should we add the new node? Okay, so we come back to see that tree. So that's earlier we said, right, we're looking for Mary. So then, right, so when I go to find the Mary, okay, so then I will have the Mary. Yeah, when I'm looking for Mary, right, greater than Fred, so I go to the right. So then I see Mary and the Mark. Mary is greater than Mark, so then I go to the Rooster. I go to the right-hand side. Then Rooster is greater than Mary, so that's why I go to the left, right? So when you go to the left children from the Rooster, that's a p equal to 0. So that's why we finish. But don't you see here, even you finish here, right? Don't you agree actually Mary also, after you come to the left-hand side to the Rooster, Mary also should be located here, right? Oh, wonderful. So that's what I mean here. Earlier when we have the loop, we find out we finish. But when we finish, actually this last node, the P we have, the left-hand side is the Mary location we need. So on the other hand, when we do our setter function, we just need to also, when we come to this point, right, we need to know the last P we have. So the last P we have, that's me. When we traverse, besides we have the P traverse around, we also need to have another node pointer. That's the priv. So that priv is keep to see where the last node before the P. So that's right. Now here we also need to add another node. This node actually is priv. So priv actually starts from 0. Right? So because when we P start, the root node we don't have the priv. So then we just need to keep counting. Before the P change, then I need to remember the priv. So that's why you see here, if they are equal to the key, I return the value, right? Otherwise, from here, I need to assign the value. So that's why priv equal to P, we need to do that before we assign the new value for the P. So that's what we need to do before here. But earlier, because we do the else if. So then, if so, how about we just remove the else if? So then here, if they return, we return. Otherwise, when we continue, priv need to do for the previous P. So then if the key less than the P refer to the key, so P equal to the P left. Okay. Otherwise, so here, if else statements, either way is fine if you want to have else or not. Okay, but the most important thing here is after we have the priv, we need to add the priv equal to P. Right. So afterward, what should we do? So actually the priv, actually we have couple situation. So we either have the Mary at the left hand side or at the right hand side. So we need to create a new node. Or you see the last one we'll check is how about they are the first node? How should we do that? So now right, if you find the key, you return the value. Otherwise, when they come here, we need to add the new node. So how should we add the new node? Right, so that's why here we need to add a new temp node. So this one is just a new node. We have the key, we have the value, we're using the default value. So then after we have this new node, right, don't forget, we always need to have size plus plus. So because this one is a setter function, don't forget to increment your size. So then after you have a new node, right, where should I add that? Right, so just like earlier, we see Mary is on the left-hand side for the user, right? But now, how do I know left-hand side or not? Because we already leave the loop. I only know this one is a pref. I need to know Mary should be left or right. So that's why when you add left or right, you need to check again. So since I know the pref, if the pref key less than the key I want to add, that means the key is greater than the pref key, right? So we'll go to the right. So that's why the pref to the right equal to the temp. Otherwise, right, so then the key like Mary is smaller than the user. So then we will have the user left equal to the temp. So after you're done, then you don't return default v now. You need to return your temp value. Look like fine, right? So that setter function look like fine. But actually, we only think about the here is you only have your pref, you go to left or right. But have you ever think about maybe the node is the first node? So actually when we have the first node, we don't have the root node yet. So then I just need to create a new node as root node. So that's why it's here. Because sometimes actually your P actually just the P equal to the root node and also root node already equal to 0. So that's why when I have the node I need to add is root node, I don't really have the parents to go to left or right. So that's why here, right, how to know the P is the root node, right? So actually we need to check the pref. So that's why here, all here, that's because you are not the root node, you have parent. But after we create the new node, you have two situations. The first situation is add as the root node. So how do I know this is a root node? Right, so that's why here, if pref equal to 0, that's why here actually the temp node I create is the root node. So that's why our root node equal to temp. So that's why here become the else. All here become else. If the pref not equal to 0, that means you are not the root node. So that's why I need to check the pref refer to the key compared to the key we're looking for. So I know I need to go to the right hand side for the new node or left hand side to the new node. So this one should be the else. So that's why here we need to add for the root node. So then afterward, no matter which one, right, you still need to return your temp value if you have a new node add. The most important thing, don't forget, sometimes we forget to increment our size. So this one is the operator square bracket setter function. So in the associative array, we don't use the push and the pop. So kind of your operator setter function is a push, because only from here is possibly maybe I didn't find the key. I need to create a new node.